this is the Science Genie again on the show. So now, this video we are going to be covering aldehydes. So aldehydes have a general formula of CnH2NO. So it's one of the homologous series that has one oxygen, right? The other being your alcohol and the other one being your ketone over there. So now the functional group of aldehydes is the formyl group, or you can say formyl group, and then it looks like this. You have this carbon being double bonded to an oxygen and a hydrogen. And note again that this will always be on the first carbon. So never find yourself in this situation whereby you indicate the position of this guy. You will be marked wrong. So here are the other molecules that you can have. You can have your molecules such as your ethanol. You can have some other molecules such as your methyl butanol. Notice again, guys, that in your aldehydes, your name for your aldehydes will always end with Al. That's going to be the suffix of your aldehyde. And then, yes, this methanol, whereby you have one carbon for the aldehyde, sometimes they can call it formaldehyde. So then be very careful maybe when they give it to you like that, and do not be confused. So let us move on to the other type of homologous series that we can have. So now we also have ketones now. So ketones also have the same general formula as an aldehyde. So just keep that in your mind, that a ketone and an aldehyde have the same general formula. And then now there's some things that you will see whereby there's a relationship that they're gonna have, but then we'll cover that in other videos when we do isomers. So now the functional group of ketones looks like this. So you're gonna have a carbon being double bonded to the oxygen like that, and that carbon always has to be bonded to two other carbon atoms. So it's not like the ketone, the aldehyde. The aldehyde always has that carbon being bonded to one other carbon, but then for your ketone, you are going to have this guy being bonded to two other guys over there. So now molecules for ketone can look like this. So you can have propanone. So now notice here I said that N starts from 3 in a ketone. So for the ketone, because of the functional group, you must always have 3 carbons or more such that you have a ketone. So now this is the first ketone that you're going to have. It's propanone. And then now there is another one here which is butan-2-on. Even if you can take this oxygen and you put it in this position, it will still remain 2-butanone. But once you take this oxygen, guys, and you move it to this first carbon, the story changes. It's no longer a ketone, but it will be an aldehyde. So be very careful when you are going to be asked to do stuff like that, whereby you have to change the position of that oxygen. And then another example for your ketone is this one, where now it has branched like this, having a branch. So then now the name of this guy will be 3-methyl butanone, noticing again that the name always ends with, sorry for that, so the name for your ketones are always going to end with ONE. That's the suffix for your ketones. So that was it about now for your ketones and your aldehydes. Let us explore more of the homologous series in the next videos. Then we will get to the practice. Thank you.